Hi, good afternoon and good morning, as well as good evening to all of you. My name is Pam Goodell, and I am the Marketing Senior Director at ITE. Thank you for joining today's initial Industry Council Product Showcase with INRIX. And just a couple of housekeeping tips, as well as a little bit of background before I turn it over to the presenters today. If you are not aware, the Industry Council was started 3 to 4 years ago as an organizational membership for private sector organizations. And the goal for the Industry Council is for the members to provide information and insight on upcoming trends as well as new innovations in the industry. And the Industry Council Product Showcase is one of the ways that these organizations meet that goal. Today's showcase is, like I said, is the first one in a series that will happen throughout 22 and 23, and hopefully as we move forward. In addition to this series of webinars, the Industry Council also has produced a couple of different publications, the most recent one on the impacts of COVID-19 in the workplace. This webinar is being recorded and will be available on the ITE YouTube channel in a few days. And so you'll be able to watch it there as well as share it with your colleagues. In terms of troubleshooting, if you're having problems with the audio, please make sure that you go to the audio section on the control panel, and make sure that you have the right radio button, whether it's the computer audio or phone call selected. That should help you eliminate any echo or other issues that you may be having. If you're having other issues, please feel free to drop a question in the question area, and I'll see what I can do to help you while the webinar continues. And speaking of questions, if you do have a question for either panelist, feel free to ask it at any time during the webinar in the question area, and I will relay it after the webinar. With that, I would like to turn the webinar over to our two panelists, Steve and Ted from INRIX, and they are going to be talking about how they can, INRIX can help agencies improve performance and reduce emissions. Steve and Ted, I'll turn it over to you.
Thank you very much, Pam. So I'm Ted Trepanier with INRIX, and I'm going to be kicking off, and Steve and I are going to pass back and forth a little bit during the presentation, and we're going to go ahead and close our cameras so folks have the full screen and bandwidth while we're actually presenting, and then we will turn our cameras back on again for the Q&A so we can talk with our hands, because I have a problem if I can't talk with my hands. So as a way of introducing and starting our talk today, click one too many times. Want to just do a quick introduction of INRIX. I think most folks in the industry are familiar with us by now, but just to assure and level set that everybody has some background. So INRIX is a mobility information provider. Our mission is to enable intelligent mobility, and our goal is to provide mission critical software and solutions for a number of different business units, including public agencies. Company has been in business for 17 years now. We were producing live traffic data across the country before either the iPhone or the Google Map existed. And since that time, we've grown, substantially, both in the coverage that we provide, as well as the types of data and data services and analytics. And so the most recent expansions relate to covering traffic data that goes beyond the car, some multimodal data, as well as different analytics, and being able to use data and turn it into information. And that's really what we're going to talk about today. We're going to focus on signal analytics specifically, but also talk about how operating signals efficiently impacts the environment and can have a big impact on greenhouse gases. And so at this point, I'm going to turn over to Steve to introduce the platform.
Awesome, thanks, Ted. So I think I'm going to set up the stage a little bit, right? So to set the stage, really it all revolves around the relationship between travel time, energy, and emissions. And I think this is logic for most everyone, but you know, we consider travel time the time for vehicles to travel between 2 points. With vehicles traveling between 2 points, the fuel expended by those vehicles are energy emitted. And as a result of that fuel used, emissions are generated and greenhouse gases are generated. And so really when you start thinking about signals, another way to look or think about this is the next layer, which is the difference between an expected travel time and an actual travel time is known as delay. And so when we're looking at delay, and I know, you know, the Highway Capacity Manual has average control delay as a metric for agencies to use to kind of score or grade their signal performance. But if you look at that delay, it generates excessive energy and excessive emissions. So essentially, you know, by removing delay, you could remove energy, or I guess save energy, or prevent energy from being wasted and prevent those excessive emissions. But another way to look at this too is there's no way we're going to completely eliminate delay at intersections. So there's this concept of excessive delay. So how do we find where our signals or where our roadways are performing less than optimal or suboptimal, and knowing that we can't get rid of all delay at an intersection, but we can find and eliminate some of this excessive delay, which creates a nice energy opportunity or emissions opportunity for us as traffic engineers to reduce the amount of fuel used or the amount of emissions emitted into the atmosphere. So looking, we've been looking at this for a little while, and we know through all the research, which I'll talk a little bit about today, but well-timed signals can benefit the environment. We know that excessive delay at intersections directly causes more greenhouse gases to be emitted. We pulled some numbers. 1 gallon of gas produces about 20 pounds of CO2, and every 10 minutes of delay at an intersection is about 2 pounds worth of CO2. And we have an infographic here that sort of represents that. So how big, when we talk about our signal timings, how big is this opportunity that we have? Well, back in 2004, many of you may have seen this before, but back in 2004, FHWA produced this composite estimate of congestion by source based on modeled data. And the takeaway here is about 5% of all congestion was attributed to poor signal timing. So 5% of all of the congestion that occurs on the roadway was due to poor signal timings. And this, just to, you know, we've used this number for a long time, but it was based on very limited data. It was, you know, back in 2004, it was very much a model data set. Recently, University of Maryland and the CAT lab have revisited this causes of congestion pie chart. And there's actually, you know, an updated version that used kind of real modern data, you know, the crowdsourced pro vehicle data to actually measure what's happening. And in this instance, they measured about 20% of disruption nationwide was a result of traffic signals. So a big chunk of that pie is directly related in terms of congestion to signal systems. And what's really cool about this procedure or process that they did, there's a website, it's down on the bottom there, the congestioncauses.ritis.org. You can even go to a localized setting. So I think you can go down to the state or county level and get a local pie chart to see how this sources of disruption, causes of congestion pie chart breaks down in your area. What we've been looking at INRIX is this scalable approach to look at all traffic signals in the United States to assess their performance. And I'll talk a little bit later on about our US signal scorecard. But in terms of where the benefit is or where we have an opportunity, if you reduce signal delay by 1 second in the United States, so average control delay by 1 second, you would save about 3.9 million barrels of oil. And if you look at those in daily numbers, that's 23.7 million hours of total signal delay, 76,000 metric tons of CO2, 200,000 barrels daily. Annually, just a ton of benefits by just reducing a single second off of your average control delay at intersections. So getting to that point of trying to better manage or better proactive manage your signals is really important. How do we get those numbers? Well, we leverage the FHWA CMAQ emissions calculator toolkit, which uses numbers from the EPA MOVES model. And we found that 1 vehicle hour of delay at signals in the US is estimated to result in about 7 pounds of CO2 equivalents and 0.35 gallons of fuel. These numbers will come up a little bit later on, but those EPA MOVES models are based on 2022 vehicle fleet, as well as a 3.24% heavy vehicles and 1 gallon of fuel equaling about 120,000 BTUs. So what we did was we essentially compiled all of that information into an INRIX green signals calculator. And I have a link later on, but if you just Google search INRIX green calculator, you'll find a calculator that will take in your assumed fleet years, the vehicle volume, the percentage of heavy trucks, and if you have an initial and final control delay, the average control delay value from a retiming project or something, you can plug those in and it'll calculate out the total hours saved, CO2 equivalents saved, and total fuel savings. And like I said, I'll get to some kind of numbers later on. I think Ted will also talk to some of these numbers that we'll go through. But it's incredibly important, especially in today's environment. So the bipartisan infrastructure law was just released, and I'm going to turn it over to Ted to talk through some of the numbers and why capturing this carbon reduction or emission savings is incredibly important, especially from a signal standpoint. So Ted, over to you.
Thanks, Steve. So picking up where Steve left off here, so I think all traffic engineers really at their core understand that there certainly is a relationship between efficient signal operations and reducing greenhouse gases, making the carbon footprint for a city, county, state as small as possible, right? And so operating the system efficiently is a big part of that. What a lot of folks are not thinking about is the money that's become available in the bipartisan infrastructure law related to the carbon reduction program. So this is fairly new, and probably many of you have heard of it, but many agencies are looking at this mostly for electrification and things that are kind of new and cutting edge that have an impact on reducing carbon emissions. But in fact, classic operation treatments, going out and optimizing traffic signal systems, qualify for funding under this act. And so this is a formula fund, and so every state gets part of this money. There's a requirement to actually develop a plan and come up with a strategy for reducing carbon. And the reason we're mentioning this is because if you're involved in that at any level at an agency or a consultant that works for agencies and you're involved with this at all, optimizing the system that you operate belongs in your strategy. You absolutely should not be dismissing or omitting or forgetting about operations as a key strategy for reducing the carbon footprint. And so signal operations, especially for urban areas and cities specifically, absolutely should be part of this program, and it's completely permitted and I think wise to, if you need additional funding to ramp up the operations area, this is a place to go to, right? And so we've included some links here for you to look at this. And again, if you're not thinking about this a lot, I think I encourage you to talk to whoever like the program manager is for your agency. So we're going to move forward here. So I'm going to talk a little bit. I got to slow down on my clicking. We're going to talk a little bit about the historical process and how we do optimize the system. So historically, the way we've done this is to come up with specifications. So we have some goals. We have a process that we define on how our agency is going to operate the systems. We either train our internal staff or hire consultants to be able to do this work, go out, collect data, put it in some sort of a model like Synchro, take those timings out of the model, go out onto the street, implement those enhancements, and then at least on part of the work that we do, not always, not all the systems, but we will do some sort of before and after analysis to be able to quantify the benefits of our work. It's in public agencies, it's very important to be able to show the benefit of what we're doing if we want to be able to get funding to do it next year. And obviously the work is significant, and for years we've been able to quantify this in reports. A lot of good before and after studies have been done and published that quantify the benefits, typically based on societal cost, but more recently usually does include some sort of an element for reduction in carbon, to put that into a societal benefit to show the benefit of doing it. And the return on investment in traffic signal timing is always quite high, right? And so typically a program of $50,000 to $100,000 of traffic signal retiming will have multiple fold return on investment in benefits. And so how do we kind of measure this, and what's been the standard practice? So agency practice for a long time, kind of the best practice for many years has been to go out and retime your system on some sort of a schedule. 2 years is really common, where we try to visit every signal every 2 years. More often if it's highly urbanized and heavy traffic volume, maybe less often if it's rural isolated signal, that sort of thing. So in the 2 to 3 year time frame, we're out there visiting all signals. And so as we think about what goes on in the delay at those signals is, delay kind of stays constant until something happens. And so typically this is a growth in traffic volume or shift in the traffic patterns. And so something impacts the operation, delay goes up. This happens continually until we get out there and visit the signal. Then we retime it. That lowers our delay at the signal, which is the benefit. So this is our ROI. But what we're really looking at here is this lost opportunity, in that it's a really mixed story when you publish a really high ROI on a traffic signal retiming project. If we go out and say, well, gee, we retime this signal and we reduce the delay by half, what that says two things. One, yeah, we did a great job of retiming, but it also says we let this get pretty bad. And it was probably that way for quite a long period of time. And so in today's world, what we need to be thinking about is that signal was actually wasting energy and polluting the environment for quite a long period of time if we have that big of an impact. And trying to visit everything on a schedule is a recipe to getting there. What's even worse, though, is what we hear more and more about is that agencies, due to budget pressures, don't even have the ability to go out and maintain their scheduled retiming. They can't get to every signal every 2 years. Sometimes it's as much as 4 or 5 years, or they're just chasing fires, right? They're going to where the phone calls lead them. And so what we're going to introduce today is a way to see the problems when they happen. And so this has enormous benefits, right? And so when something happens that impacts the delay at the signal, you can see that right away, go out, make an adjustment, and get the signal back into an optimal state. And so what this does is it reduces that waste, that significant waste over time. It also helps you deploy resources to the places where you can have the most good, do the most good, rather than working on a schedule. So it's just a win-win. So this type of work has been talked about for some time, and one of the ways to be able to focus that work is using advanced traffic signal performance metrics. And there's been research done on the benefits of implementing signal performance measures. And just like some of the things we're talking about here, having ATSPMs allows us to have data and use data-driven decisions on our priorities, both capital programming as well as scheduling optimizations, signal retiming projects. It allows us to see these detrimental effects, right? Whether it be a shift in traffic or an equipment failure, we can actually see those things in the data and go out and make correction. We can use the data to actually determine the necessary adjustments, and then we also can use the data to quantify the benefits and do the before and after studies. Now, ATSPMs are traditionally thought about as being implemented via detector-based systems, so connected software where we have comm to traffic signal systems, and we're pulling the metrics in based on detector data and generating the metrics that we use to optimize the system, which is great. And a lot of work has been done in this area, and it's all really good work. The challenge is that it's expensive. It's expensive and it takes time to deploy the systems, and there's actually very few agencies that have all their signals that connected and have detection on all the approaches to the point where they really have apples to apples data across their entire system to be able to use the data to know where to go, right? And so what we're talking about today is a different way, a way to move faster and a way to actually move more efficiently and monitor an entire system and make these changes at a much lower cost. So I'm gonna turn back over to Steve to talk about the system.
Great, thanks, Ted. So this is a product showcase. So let's talk about our product. So the product is called INRIX Signal Analytics, and I'll go through and show some examples. But I like to kind of start the conversation by dividing it up into three areas. The first area is the data. So we're taking data from vehicles, from connected vehicle GPS points that are providing kind of breadcrumb trails or waypoints at 3 to 5 second frequency. We take that and we turn those into traffic signal performance measures. And then we present all of those performance measures in a series of tools that an agency can use to proactively monitor and measure their system. So I'll talk about each one of these things individually here. But so the data, we get a lot of questions on the data. Once again, I'm gonna say it kind of at the top. Ted mentioned it. There is no detector data that is coming from into our platform. This is completely and totally based on waypoints from GPS vehicles. So I'm sorry, GPS devices within vehicles. So it's connected vehicle data. It's data collected from the GPS devices built into the vehicle. This is a subset of the entire INRIX data set that's used for a slew of our products, but we're only using high frequency waypoint data. So we're only using data that we're seeing provide waypoints every 3 to 5 seconds. And I'll reiterate, but there's no infrastructure required. So we don't have detectors in the field. There's no maintenance, no installation of detectors. We don't even have anything in the cabinet. So we're not plugging into a controller or requiring comms from a controller in the cabinet. It is completely and totally based on this high frequency waypoint data. In order to do that, we had to make a few assumptions. So when we start talking about our assumptions for developing these metrics, you can see, I think traffic engineers will appreciate a time-space diagram and or a trajectory plot, if you will, but time on the x-axis, distance on the y-axis. You can see a vehicle kind of making its way through an intersection. And really what we're doing is tracking that vehicle's experience through the intersection. So in order to do that, we need to make some assumptions. The assumptions are we look at a vehicle 150 meters inbound of the intersection. So that's when we start, monitoring the vehicle through the intersection, and we go 80 meters past the intersection. So from that 150 meter inbound and 80 meter outbound, what we're able to do is derive a travel time. So we know when the vehicle entered our zone, and we know when the vehicle exited that zone. So we're able to determine a travel time of each vehicle as it's made its way through the intersection. Does not matter if this vehicle made a left turn, went through, or made a right turn. We can, we do the same kind of methodology and are able to provide a detail of this vehicle's experience as it goes through the intersection. Other metrics that we can provide. So based on our data, we know the speed of the vehicle as it is approaching the intersection. We can also look at all of the vehicles that made its way through this intersection, or all intersections, and determine a reference travel time. And so our reference travel time right now, after some comparisons, is a 5th percentile travel time of vehicles that did not stop as they made their way through the intersection. So we can then compare each vehicle's experienced travel time with that reference travel time to calculate a delay value. So we know the control delay value of every vehicle that made its way through the intersection that we have a record of. Another metric that's really important to us is the number of when a vehicle stops. So mentioned we have arrival on green metric. Well, if a vehicle stopped at an intersection, we assume that vehicle arrived on red. And we consider a vehicle stopped when we see a waypoint that was less than 6 miles per hour. How did we figure out less than 6 miles per hour? We did some comparisons with ATSPM data and infrastructure-based systems to kind of fine-tune that number. And this 6 mile per hour number popped out as the best number to use. So what does that mean? It means for every intersection, we're able to provide different signal performance measures based on these observed vehicle experiences. So just based on those arrivals and departures, we can provide travel time, approach speed, control delay, level of service, turn ratios, vehicle counts, split failures, and stops or AOGs. And so without any infrastructure in the field, without any detection, without any communication out to the cabinet, we can really give you a good idea of what's happening in your network or on your system. And so shifting gears, when those are the metrics, so we provide those metrics. And how do we provide those metrics? Well, we provide those metrics through our signal analytics platform. And there's really 2 tools that we use. There's the INRIX IQ signal analytics, as well as the CatLab signal analytics platform, but they're web-based tools. No data storage or software installation is required. It's a website. It's complete coverage, so any signal in a network we can provide information for, and it's ready to use. So as I mentioned before, no infrastructure required. It's really about just turning it on and enabling performance measures at each intersection. We have various dashboards, which I'll go through. We have a dashboard view, an intersection analytics view, a corridor analytics view, and then CatLab's custom reports features, which all have various use cases. So as I just mentioned, Ted's going to dig into some additional use cases and some actual customer use cases. But when we built this platform, we had 5 core use cases in mind. Scanning your entire network, so having metrics for every single signalized intersection in your network and being able to look at them all, and they are all measured the exact same way. There's no changes in detection from one intersection to the other. It's the same, the same measurement for each intersection in your network. You can identify where intersections have degraded. So Ted showed those kind of blips in that graph. Being able to identify when that performance significantly degraded allows you to be more proactive. You can discover, deploy, and measure small iterative changes. So once something happens, or if you think you can make it better and you just want to tweak and maybe add a couple of seconds of green, or flip a phase or something like that, you can deploy and then investigate and see what happens to your performance metrics. Perform systematic before and after studies. So how did you impact with a retiming project or that iterative change, and then verify the results of traffic modeling or simulation software. So Ted mentioned standard is Synchro or Bistro, but there's a few different modeling softwares, and being able to actually measure or understand if those models were correct, and if you still have or if you have any issues on your system. So diving into the platform a little bit, I've got a few views here. But when you would log into the Signal Analytics tool, what you would start with is this dashboard view. And so this dashboard view we're showing is for Austin, Texas, but it shows the number of intersections they have licensed and some summary statistics about their entire network, as well as kind of a week-over-week comparison and intersection count by level of service over a 24-hour period. So we have a daily report. You get this same dashboard every single day. These two charts or tables on the right here are really important and really cool. What they're able to show is this daily report, the top 5 intersections that degraded relative to their 4-week average. So in this case, this North Capitol of Texas Highway, the 4-week average was operating at level service at B. The last daily report, it was operating at level service of C with a significant amount of kind of degradation in terms of the performance of the intersection based on total control delay. We also have this in control delay per vehicle. And then we have this for corridors as well. So looking at the corridor as a whole from start to end, and you can identify the corridors that have worsened relative to the 4-week average. So really using this to identify if there's any issues in your network that are different than what you would expect in that 4-week period. Oh, we go back up here. Went too far. So once you're out of the dashboard view, or if you click on any of those intersections that are in those tables, what you'll get to is this map view, and the map view is really powerful. What you can do is look at every intersection you have licensed in your network, and you can click on any of those intersections, and you can color it based on level of service. So control delay. You can also color it based on change in control delay. So essentially, if things are better or if things were getting worse than expected or better than expected, and as well as any of the metrics that I've mentioned previously. But you click on one of these intersections and you get this intersection diagram that shows you by movement at this intersection the performance measures that we mentioned. So in this case, looking at this West Cesar Chavez, we had 52 vehicles that we observed make a left turn, and the average control delay of those 52 vehicles was 42 seconds. You can also, this is a 24-hour period. You can also break this up into AM peak periods and PM peak periods to get a better idea of performance during those periods. Clicking one further, we also have street view or aerial view, so aerial photography that you can use to kind of investigate your intersection. We have approach level metrics, so we can aggregate up to the approach, and you can click on an approach or a movement, and you can see the metrics over time. So in this case, we clicked on this kind of northeastbound approach, and you can see that significant volume in the AM peak, but a lot of these vehicles are arriving on red. The greens are the vehicles that are arriving on green, and the dashes here, the hashes, are where we observed a split failure. So split failures are determined if a vehicle has stopped and then moved and then stopped again. We consider that a flag for a split failure. So you can get a whole bunch of metrics here and really drill down to individual intersection level metrics. Another really cool part about this platform is you can look at every intersection in your network. I mentioned this before. One of our core use cases was how do you scan your entire system? So there's a list view that you can go to, and for any of our performance measures, you can sort by that given performance measure. You can also, if you're looking to get some of this information to Excel, you can download this list view. It'll get it to an Excel file, and you can run your pivot tables or Excel gymnastics that you want to look at trends and other pieces. But this list view is really cool. Intersection level metrics for every single intersection in your network. I'll talk about two more things briefly. So we also have as part of this platform, there's a corridor analytics tool, and the corridor is based on very similar to Bluetooth Wi-Fi MAC address matching, but no infrastructure again required in the field. You select a start point, you select an endpoint, and we start telling you travel times from the start point to the endpoint that traveled along the route of choice. And we could show the hourly vehicle count as well as various travel time statistics on that corridor. So when you start looking at coordinated systems and you want to understand whether you're making, doing some type of offset adjustment or making trying to get coordination right, you can use this tool to look at across a series of signalized intersections. Finally, we have our partners at CatLab who have intersection analysis tool that can be used for custom reports. And this is really cool if you wanted to stack data, meaning you want to look at more than just one day at a time. You can look at a week or a month. Or if you're really wanting to drill into a particular time of day, you can say, okay, well, maybe I want to look at Mondays between 6 and 7 a.m. For the last 5 or 6 weeks. You can do that. So you plug in which intersections you want to look at, your times, your time periods, and it'll generate a report very similar to what we have in the IQ platform. But the report will look something like this. It'll be an interactive report that you can go through and look at all of the various performance measures for the time periods that you selected. So a really powerful tool to be able to kind of use. And you can do filtering and other things as well on those metrics that are provided. So we've worked really hard on this platform, and we're getting to the point where we actually have folks starting to use it. So I'm going to turn it over to Ted to talk through some of these use cases.
Thanks, Steve. So I'll go fairly quickly here in the as I know our time is getting somewhat short, but I just want to give some real world examples of use of the platform to get the benefit that we've been talking about so far today. So the first one here comes, and these first three actually come to us from Washington County, Oregon. So this is a kind of semi-urban area near Portland, Oregon, if you're familiar with it. And the first use case is simply using the dashboard to identify where things, essentially have gone wrong. And these could be related to shifts in traffic or equipment. So one of the use cases Steve called out here. And so one of the they do is simply check the dashboard every day to see if we're seeing the same intersection pop up repeatedly, right? So if the same intersection is at the top of the list and near the top of the list for more than a day or two, then it's worthy of investigation. And so this is an example of where intersection was top of the list several days, went out and found out that the comm was down, right? And so it was equipment failure, took a corrective action and fixed that. The second use case, very similar, different intersection popping up top of the list, and go out there and sure enough, here's a hung up loop card, right? So detection failure in the system, correct that and problem solved. The next one here is a little bit more interesting. And so this is kind of related to the system-wide scan to find the problem that was hiding. Great example of this. And so kind of an innovative way to look at the data that they came up with there is to kind of log the intersections that are in the top 10 list ranked by split failures. And then create a list where they rank the percentage of the time that an intersection showed up in that top 10 list. And obviously the intersections that are oversaturated, your busiest intersections, probably the ones that are the most familiar with you or to you, are going to show up on this list. And so that's not a huge surprise. It's not going to provide a big benefit to see those intersections. But what you're looking for here is an intersection that you weren't thinking about, right? So an intersection that isn't top of mind as an oversaturated intersection, isn't top of mind as a constant problem area, and essentially, but does have a problem. So it's a problem that was essentially hiding. from you, right? And something you weren't aware of, and that's the value of the platform, is to be able to find that intersection. And so that's the case here, right? So when we look at this intersection, Northwest Cornwall Road and Murray Road, was one that didn't appear to them, was not well known. It's like, well, there shouldn't be happening split failures there, right? And so let's take a look at that, right? And so went out, pulled some data from this intersection, and what I've done here is gone into the Cat Lab tool and pulled data for 3 weeks before and after they actually made adjustments. So you look back, when you find out about this, pull data for the intersection, you have the ability in the platform to look across multiple days. So we're stacking data for a 3-week time slice, and looking at all the movements around the intersection. And sure enough, here's this left turn movement with 39 split failures and very few split failures on any of the other movements, right? And so this is certainly an indicator that the intersection is not oversaturated. We just simply have a split that's off. Could be a detector problem, right? So this is kind of what you need to go find out. So they went out and took a look at it, and sure enough, adjusted the max time. So this was a split issue, was not an equipment issue. So entered in the log that they increased the max time from 25 to 35 seconds, and seemed to solve the problem. So we can certainly go back into the platform then and check. So we've pulled up data now for 3 weeks after they made the adjustment, and look at the same movement and only 3 split failures. So again, looking at the before and after, we had 39 before, 3 after, and really didn't increase splits around the intersection on other movements. So exactly the kind of thing that you want to accomplish with the platform, right? We found a problem, fixed a problem, measured the result. This next use case is one that I think resonates with a lot of folks that work in operations, and that is responding to customer complaints. So these are our citizens giving us feedback, and one of the things we don't like is when they find the problems. But it always is, it's how we often do, and certainly worthy of investigation. So we had a person here who called in and related that it was taking them, longer to get through the first couple intersections after they exited the freeway as the whole rest of their journey, right? And so could you guys take a look at these things and see what's going on here? So sure enough, easy way to do that is to go into the dashboard. First thing you do is kind of look at the day that the person was relating the incident on and verify that in fact there was an issue. Sure enough, there was. Then you can simply click back the previous few days to see, did this problem just happen on one specific day, or has this been a problem recurrent, right? Is this happening on multiple days? And sure enough, the dashboard shows that this was an issue for multiple days. So went out, made an adjustment, long story short here, and then just looked at the dashboard over the next few days, much improved, right? And so essentially fixed the problem, we can move on with our lives, solve the citizen problem. Now, using the energy calculator, we can look at the side benefit. So not only did we solve the citizen's delay problem, fix their life, but if we were to annualize the benefit of making that adjustment, nearly 2,200 gallons of fuel will be saved over the year, because we found this problem and fixed it, and didn't let it continue to linger until we went out there and maybe found it during a routine retiming project. So net, we're talking about reducing 22 tons of carbon from the atmosphere. So next couple of use cases come from the city of Austin. So Kimberly Horn works with the city, staffing their arterial operations center, their multimodal arterial management center in the city of Austin. And one of the things they've started to do is actually roll up the benefits of the actions they're taking. So they're doing a lot of the same kind of work that we saw in Washington County, but now we're also doing a quarterly report. to say, okay, of all the actions that we're taking, what's the collective benefit of that? And so I thought this was a really interesting summary, and shows again the significant benefit, right? And so across just 1 quarter, you got improved average delay for everything they touched by 32%, based on just analyzing 22 intersections, right? So responding to 22 different incidents. So the cost benefit, right, is well, the passenger benefit was over $200,000, right? So certainly in the plus category as far as an ROI goes. Also, really easy to understand how that would have significant climate benefits, right? So one of the things we'll do here that we just haven't had a minute to do is to go in and actually get the numbers underneath this, so we can actually quantify that benefit as far as reduced carbon. But certainly with that level of societal benefit, it's going to be there. Then the last view that we're going to talk about is retiming adjustments. So obviously Austin is host to a number of special events, biggest being South by Southwest, and it's a 2-week event, right? And so they actually looked at the dashboard over the first weekend to find intersections that were having issues, were significant delay, to go out and make adjustments for the second weekend. You can see here, retimed 1 intersection and got a benefit of 32 seconds. And so the issue here, the interesting thing is that this intersection was not near downtown, so it wasn't near the event. It was kind of like beyond the radar, right? It just kind of sits on the periphery, but was impacted by traffic. And so without having a system that looks across all the signals, you wouldn't necessarily see this sort of an issue and be able to go to address it, right? So a couple other intersections, and they actually sent us a bunch. But in the interest of time, we'll just click through. And obviously, every one that they went to, they weren't able to improve every single one, but several, right? And so a significant benefit, especially if you think about it collectively, right, on the whole. So I'm going to pass back to Steve to close this out here and talk a little bit about signal scorecard work that we've done. So Steve, we are getting short on time.
All right, thanks, Ted. So yeah, I will talk briefly about this. So we just released an update to our US signal scorecard, and once again, with the power of this scalable approach to look at intersection performance, we were able to evaluate all of the intersections that we had available in our platform. And so there's more information at INRIX.com, or if you Google INRIX signal scorecard, you can find find more information. But we did just kind of do a nice refresh of our signal scorecard for you to take a look at. It includes a subset of the metrics that I had talked about previously. I think one of the really cool parts about that effort is, if you want to look at kind of get a taste of the scale, there's a link here in Mango Maps, or it's a map that shows all of the signals that we were able to evaluate with this scorecard. So you can zoom in and out and get some of the metrics for your local area in the map view. Looking at summaries, it's really hard with COVID times to look at comparing our original report with the new report. All of delay and volumes and everything is up as a result of us getting closer to normal. But we're still seeing some interesting tidbits throughout our report. So I mean, AM and PM peaks are starting to come back, and we can look at that by various different performance measures, whether it's arrival on green or delay. You can start seeing these peaks from 2020 and 2021 to come back. And there's a lot more information on that on our website. But one of the really cool parts about this was we were able to use that energy metric calculator that I had discussed before to look at, just kind of hypothetically, if we take a look at the CO2 and oil and all of those national reports, if we annualize those numbers, the CO2 generated by signal delay was nearly 28 million metric tons. For all of signal A, 72.7 million barrels was used. The impact of a 1 second change in average delay per vehicle, there's real meaningful impact for reducing the amount of delay at these signalized intersections. So, in the tune of 3.9 million barrels or 1.5 million metric tons of CO2. We did plug the values from the original scorecard to the previous scorecard into our system, and because of the increase in the volume and everything else, we are seeing a kind of an increase in carbon dioxide, which is expected. But if we can manage this increase in fuel use and carbon emitted with optimal signal timings, there's real benefit to be had here. So I know we're running short on time, so just in conclusion, the signal analytics platform is really a scalable approach that you can look at every single intersection in your network, and leveraging these tools, you can identify and improve these underperforming intersections. And as Ted mentioned, please, the bipartisan infrastructure law funds are available to really target some of these carbon issues, and this tool provides you a way to have meaningful impact now. And so with that, I will say thank you, and then we can kind of open it up for the questions in the chat.
Great, Steve and Ted, thank you both so much. That was a very informative webinar. I think people had learned a lot from it. So we do have some questions coming in. This should hopefully give some people some other time to type in their questions. The first one I want to just answer is about the slide deck. So the recording of this webinar will be available on the ITE YouTube channel shortly, and I will email everybody who is participating or who registered when it is available. Ted and Steve, what about the slide deck? Can people email you for the specific slides?
Yeah, so we have our email addresses up on the screen now, and if you just reach out to us, happy to send you a copy of the slides, or if you've got a specific question or something you want to drill into there, happy to drill in and send you some slides on that or even more information. I also see a question there about available links, to the scorecard map that Steve just showed, and so it's on the screen now. Also can find it fairly easy by going to the INRIX website.
Okay. While people are perhaps getting some questions ready, so you mentioned Austin a lot as some examples. Can you share some other communities and agencies that you've worked with that maybe are in the scorecard, but you can just mention now?
Steve, do you want to call out some, or?
Sure. So yeah, we have a bunch of customers, from state DOTs to cities to MPOs. I know Washington County and Austin are certainly power users. We also have Rhode Island. There's folks in North Carolina, as well as folks in Nevada that are using the platform. And it still is relatively new. And we're starting to get more feedback and incorporating that feedback into the improvements that we're making in the platform. So stay tuned too. We've got a lot of updates coming along for our platform, but we're excited to hear to get more use cases from our customers that are using this product.
Yeah, well, and that's great, and it's good to hear that you're making improvements. What kind of drawbacks? I know you indicated that you had made some assumptions because you're not going into the cabinet specifically. Are there some drawbacks to the assumptions that you've made, that you've experienced already, that you're working on fixing?
That's a really good question. So I think originally to scale, we were certainly, we get questions like this all the time on how did you come up with that inbound and outbound distance? And we did do some assessment using ATSPMs, and we actually kind of based the initial assessment on where someone would put an advanced detector. And we've been getting some comments, and certainly valid ones, that says we're kind of putting a restrictor plate on the power of our tool. Like we don't need to stay at 150 meters inbound. We can extend that further out. So that's one thing that we've heard from a few customers. Ted, I'm not sure, you talked to a lot of them too. Is there any other feature requests that we're getting that we're kind of starting to incorporate?
Yeah, so one of the things due to the time that we really didn't even get a chance to talk about today is the corridor work, right? So again, there is, we have intersection level metrics, but we also inside the platform now, we've added performance measures for corridors so folks can assess coordination across the corridors. And then we also scale the numbers up to give some total delay factors. And the scaling is a hard thing, right? And so I think anybody that does traffic volumes system-wide without having detectors knows the challenge there. And obviously there's an acceptable band of accuracy. Well, as you scale, right, some of those things can be somewhat off. And so that is something that the scaling factors that we're still kind of playing with a little bit, right? And so the core data is all based on the actual observations, so super solid. The scaling part of it is something that we're still working on.
Great, thank you. So I have a couple other questions. We may run a little bit over time. If there are other questions, I would say that now is the time to ask them, but I'm going to go ahead and ask these other two questions. In general, what is the length of time that it takes to deploy your system?
So that's a really good question. And one of the powers of this tool is because we're running these national scorecards and we're looking at every signal in the country, really to get the system up and running, it's only a couple of days. And then we'll spend a couple of weeks working with the customer and make sure everything is working appropriately. But it really can be turned on and ready to use in a matter of days to a week. So it's almost immediate.
Okay. And I guess the last question before we wrap up is, you mentioned a number of performance measures that you look at. Do you work with the agency specifically? Do they have impact on deciding like a preference or where they can put more impact or on a specific performance factor?
So that's another really good question. It really depends on the agency's objective. And so, percent arrival on grain is a really good metric if you're trying to coordinate your system, right? It might not be a great metric to look at, side street performance. But we also have split failures, and we've had agencies tell us that they consider split failures a safety proxy. Meaning, when vehicles are sitting there and waiting through numerous cycles at an intersection, the drivers can become more aggressive and actually, cause crashes at that intersection. So it really depends on your agency's objectives. But we try to include a slew of different performance measures, so the agencies can use those for whatever objectives they may have. Ted, I don't know if you want to add anything to that.
Yeah, the only thing I would add is, we're working with the folks in establishing user groups to kind of think about what we should build next. So it is one platform, right, that everybody sees. And so this is, again, like a lot of software solutions, what we hear from the clients, we use to help guide what we build, that then whatever we build becomes available to everybody. Right, and so we don't build a specific performance measure for a single agency, right? If that we hear that a certain performance measure is going to have value, then we're going to bring that to everybody.
Great. All right, well, I think that just about does it, both for our time as well as the questions that I have been given. So Ted and Steve, if you have some wrap up, just closing remarks, we'll go to that, and then we'll just close out for the day.
I'll turn it over to Ted, but thanks everyone for coming today, and thanks all for listening, and please check out those web resources. I think there's some valuable insights into how we're doing this and where we've come over the last year or so. And Ted, I'll turn it over to you for the final remarks.
Yeah, I will just add my thank you for joining us today and close by saying don't be shy in reaching out to us, right? So we give folks a trial access to platforms and showcase data that we have available, and even just happy to discuss, what we're doing and where we're going. Just feel free to reach out to us anytime. If you want a demo or simply want to discuss where we're going, happy to chat with you.
Wonderful. Well, everyone, thank you again for joining us, and I hope to see you on another webinar shortly. And Ted and Steve, thank you so much for a great presentation.
Thank you, Pam.
Thank